Alright folks, today we're going to be talking about periodic trends, atomic radius, and ionic charges. So let's get going. There's a lot to cover here. The properties of elements change in a predictable way as you move through the periodic table. So as you think of your periodic table, it's designed in such a way that you can find trends as you look at the table itself. Now, today we're going to talk about atomic radius and ion charges, and our next podcast is going to be on ionization energy and electronegativity. Alright, so what is atomic radius? Think of a circle. A circle, your radius is from the center to the edge, right? You all know that. How does that apply to an atom? Well, to an atom, we have the nucleus in the middle, right? And around the outside, we have what we call a shell for our electrons. Now, remember, this is where 95% of the time we're going to find the electron inside this area. So it's not a physical shell, it's just 95% probability we're going to find the electron in here. And that's what we're calling our atomic radius. Okay. Now, what happens as I go down the periodic table? Well, let's look at column 1, group 1, and we'll look at hydrogen. And hydrogen has one proton, and hence it has one electron. And that one electron is going to be in the first principal energy level. Remember, your first principal energy level is here, your second one's there, third one's there, fourth one's there, fifth one's there. Remember the 1s, 2s, 3s, 4s, etc. That's what we're talking about. Okay, so your first principal energy level is here. Now, what happens when you go to lithium? Lithium's number 3. It has a nucleus, slightly bigger than the last one because it has 3 protons in it, and your first energy level now has 2 electrons in it, but you have a second energy level out here, which has 1 electron in it. How about when you go to sodium? Sodium's number 11. Right? We still have a nucleus. We still have a couple of electrons in your first energy level. We now have a total of 8 electrons in your second energy level. We have 1 electron out here in your third energy level. So it should be clear as we go down the periodic table that things are getting bigger. The radius of our electron cloud is getting bigger because we have new principal energy levels. So, our quantum number of the outermost energy levels is increasing from 1 to 2 to 3 to 4. So, the electrons with a larger principal quantum number are found in orbitals that extend further from the nucleus, which makes the atomic radius bigger. Now, when you go across, you might have something that isn't as clear. It's not as intuitively obvious as to what happens here. So let's look at lithium. Lithium is number 3, and it has, stop that, it has a nucleus, and it has 2 electrons in its 1 level, your 1s level, right? And it also has an electron in its second energy level, only 1 of them. But what happens if we come over here and we look at fluorine? Now we're in the same period, okay? So fluorine has a nucleus, and it has 2 electrons in its first energy level, and then in its second energy level it has a total of 7 electrons. But what's going on? Let's think about the electrons in this first energy level. Just think of those for just a second. Over here with lithium I only have 3 protons in the middle. Over here with fluorine I have 9 protons in the middle. So, which would these negative charges be more attracted to? Well, certainly they're going to be more attracted to the nucleus that has 9 protons in it instead of only 3, which is going to make this inner energy level of your 1 level smaller. Well, if it makes the first energy level smaller, consequently, it should make the second energy level smaller. So, fluorine is going to be smaller than lithium, because it's in the same period, but it has more protons in the middle, and hence it's attracting those electrons in more. Okay? Think of it like a dance. If you went to a dance, right, and you had, let's say, a wall here that you couldn't get through, right, but there were 3 women in the middle, your guys out here, there are 3 girls in the middle, right, and then you have one where there are 9 girls in the middle, right? What's going to happen to this fence on the outside? Well, out here you've got one guy pushing in. not much is going to happen. Out here, you've got 7 guys, all pushing in, trying to get to those 9 girls. What's going to happen to the fence? Yeah, it's going to be pushed in. Right? So these are all going to get smaller. So this guy will actually be smaller than this one over here. Now, if you had 11 electrons, you'd end up with another whole ring out here. So that doesn't apply. That's when you go down the periodic table. But just going across, it gets smaller as you go across. So as we go across, we look, these over here are smaller compared to these over here, which are larger. Okay. So, as you move from left to right across the periodic table, the atomic radius decreases. Okay? So as you go left to right, it's small over here. Now, and in any period as you move from left to right, the nuclei gain more protons. More protons, more positive charge, bringing in those electrons more, stronger pulls. Okay? So the atom becomes smaller. So based on this, where's our smallest and largest element going to be? Pause the video, see if you can write that down. All right. Well, we know that as we go down, we get bigger. So if I look down here, we have to ignore this. Remember, these guys fit up in here, so we're just going to kind of ignore them. Right. Your biggest one has to be down here at the bottom. So it could be francium or francium or whatever. Or it could be something down here like this guy or whatever the missing guy is down here. Could be. So. But what about as we go across the periods? Right? As we go across the periods, we get smaller over here. We get larger over here. Right? So as we move right to left, we're getting larger. And as we move top to bottom, we're getting larger. So that tells me the biggest thing has to be down here, which is francium. Where's the smallest thing? It's going to be opposite that, so it's going to be way up here. The smallest one's going to be helium. That's important that you know that. Write it down. All right, so what happens when I become an ion? How in the world do I become an ion? Well, again, let's look at a dance. Right? If I have a dance and I've got the 3 girls in the middle, again, I'm going to use lithium, and I have one guy way out here, right? Whereas if I have 9 girls in the middle, again, I've got 2 boys sitting here, and then I've got 7 boys out here. Which boy could I pull away the easiest? Well, remember, this is smaller. This is fluorine. This is smaller. And over here, this is larger. This is lithium. So where can I pull an electron away? Well, I could pull this electron away over here easier because he's further away from the nucleus. These guys over here, I can't pull away as easily because they're closer to the nucleus. Okay? So, it's easier to pull you away if I'm small. If I'm not small. Okay. Let's look at orbitals. Well, again, you've got a 1s orbital, and you've got a 2s orbital. Over here for fluorine, you've got a 1s orbital, you've got a 2s orbital, and you've got some 2p orbitals going around like this. One coming out of the board at you. Okay? Well, these are all within this level, if you will, this shell, this second energy level, and they're being attracted by 9 protons, and over here you've only got 3 protons. So it's going to be easier to take this one away from here, and this one over here is going to want an extra one, actually. So, electron configurations, let's look again at lithium. Lithium is 1s1, 1s2, 2s1, whereas fluorine is 1s2, 2s2, 2p, 5. Well, if I think about it, this only has 1 electron in its smallest energy level. And this has 7. And you don't know it yet, but the most you can have is 8. Right? So this electron is going to tend to disappear. And this one is going to tend to want one to make that up to P6. And that's where we're going. Because atoms tend to gain, lose, or share electrons in order to obtain the electron configuration of a noble gas. And noble gas would be P6. Because 1s2, 2s2, and and 2p6 has a total of 8 electrons in the second energy level, a total of 10 electrons total, and if we bounce back to this, we'll notice that the element that has 10 electrons is neon, which is a noble gas. Okay? So, your ionic charge, what charges do things take on? Well, the things over here, we already said the things that were in column 1 tend to lose an electron. So if they lose an electron, they're going to take on a positive charge because they lost an electron. But they only lost 1 electron. How about these guys? Well, they're going to tend to lose 2 electrons. We've already said the noble gases don't gain or lose electrons at all because they're very comfortable. They have that full electron shell. But fluorine will want to gain an electron. And when fluorine gains that electron, it gets a -1 charge. How about oxygen? Well, it could use 2 electrons to get up to 10. It would take on a -2 charge. Nitrogen could take on 3 more, and we don't have a 3 going the other way, so boron could lose 3. How about carbon? Well, carbon actually is sitting right in the middle. Carbon could, in fact, lose, or carbon could gain 4 electrons. It really doesn't matter to carbon, it's sitting right in the middle. Okay? Now, if you haven't written that down on a periodic table, please stop the video, grab a periodic table, and write that down. All right, so now that you've written that down, what charges do these things have? Pause the video, fill this out, make sure you can do this. All right, if I look at chlorine, chlorine is a halogen. It has a 1- charge. And magnesium is in group 2. It's an alkaline earth metal, so it has a +2 charge. Aluminum has a 3+ charge. Potassium is an alkali metal, so it has a 1+ charge. Nitrogen has a 3- charge. And silicon is sitting right below carbon, so it can have a +or -4 charge. How about argon? Argon's a noble gas. It does not bond with anything, so it has no charge. Okay, let's look at an ionic size. Let's just look first at lithium. Remember, lithium is lithium-3. And lithium has 3 protons in the middle. And then it has a 1s orbital with 2 electrons in it. And then it has a 2s orbital with 1 electron in it. Now, if I want to become Li+, what happens? Well, I have to lose this electron. If I lose that electron, what happens in here? Well, I've lost an entire shell. So all of a sudden, I still have my 3 protons. And now they're holding on even tighter to the things that are in the 1s orbital, my 2 electrons there. And remember, now I'm missing all this outer shell. It doesn't exist anymore. All right? So what's happened to the size or the radius of my atom? It's gone smaller. So if I go positive, if I move towards positive, it gets smaller. Conversely, what happens if I do fluorine? Well, logically, it should get bigger, right? And in fact, it does. If I have 9 protons in the middle, and that means I have 2 electrons there and 7 there. What happens if I add an electron here to 8 to make it 8? Well, if I add an electron, then these electrons that are in here are all going to repel each other just a little bit more. So I will actually, if I become negative, I will get bigger. All right. So, ionic size. When an atom gains or loses an electron, it forms an ion. You already knew that. If it loses one, it becomes a cation, and it becomes smaller. Right? You might want to write that down. The term cation, we'll be using that a lot in future podcasts. But from this podcast, you really need to know that it's gotten smaller. If it loses an electron, if it gets positive. One less electron reduces the electron repulsion. We already said that. Now, if it gains an electron, everything is backwards. It becomes negative, so it becomes an anion. It becomes larger. You need to know that it gets larger. And the greater number of electrons increases the repulsion between all of the electrons, pushing them away. Okay, so you need to know what atomic radius is. Know that it's from the center to the edge of the electron cloud. You need to know the smallest and largest elements. The smallest one is helium. The largest one is francium or francium. And you need to know the charges for the main block, +1, +2, +3, ±4. minus 3, minus 2, minus 1, 0. And you need to know that when ions are positive, they get smaller. When they get negative, they get bigger. That's it. Questions? I'll see you in class. Have a good one. Bye.